Thank you.
Geldi.
Hello, everyone. I will welcome 11th International Congress on Mathematics, Engineering, and Natural Science. I will do the moderator for this section. My name is Didem Kahya. I am working at Ankara University Science Faculty Chemistry Department. And now I'll leave the floor to Ms. Öz Yılmaz for her speech. Yes, it's your turn,
Hi.
Ms. Öz Yılmaz.
Hello.
Okay. I am going to.
Morning.
Oh. Hi, my name is Ayşe Özilmaz. I am from İskenderun Technical University, Hatay, Turkey. Today I'm going to present my study titled Gender Effects on Elemental Composition in Ray Liver. I work with cartilaginous fish. This is one of them. This is a cow nose cartilaginous fish. Other than the other fish, this cartilaginous fish skeleton made with cartilaginous. Some cartilaginous fish are caught either aimed or not, but generally not aimed out of target byproduct. Their livers sometimes have been discarded to the sea. Sometimes their muscle can be used or their fin can use, but their livers discard. So I here try to give some information about this livers elemental composition, because some previously reported studies show that liver of cartilaginous fish could be used for raw material. So it could be as a good raw material, such as pharmaceutical or cosmetic industries. So it is necessary to investigate the elemental composition of this fish liver. Elements are naturally compounds in world, including aquatic ecosystem. However, their presence might increase with some human-originated activities, such as aquaculture and agriculture activities, industrial waste, and domestic use, among the other increases with their levels in aquatic habitats. Some elements can be considered as pollutants and some are not. Elements such as iron, copper, zinc, and manganese, microelements, sometimes metals, they play an important issue in our lives. Some elements are classified as pollutant only when added by man in sufficient amount to produce harmful effect on some features of the ecological system. Northeastern Mediterranean Sea is an important geographical area shared by numerous aquatic species with pollutants, and there are many heavy marine traffic in this area. Aquatic organisms are the only who affected by elevated heavy metals in their environmental, especially when they are there are some thresholds such as Turkish Food Codex, FAO, and who sets minimum and maximum levels, sometimes just minimum levels for these elements. The objective of this present study is to determine some micro and macro elements in male and female cow nose river. One cartilaginous fish, this ray fish species belonging to the elasmo branch, found in fish in northeastern Mediterranean. Materials and methods. The cartilaginous fish obtained from Mediterranean Sea, and the microwave assisted method was used to digest the organic matter. Approximately 1.5 gram of liver tissue was subjected to wet digestion method. This procedure was carried out according to AOAC method. The sample was weighed and a total of 2 milliliter of perchloric acid and 8 milliliter of nitric acid added to samples and weighted in fume hold because the samples are very oily, and we cannot just put them in the microwave right away. So we have to incubate them until the dense gas out decreased. The digested were filtered in the volumetric flask using ash-free filter paper, and the volume up to 25 milliliter with ultra pure water. One-way ANOVA was performed to see the difference between gender, and the significance was established at P lower than 0.05. This is the microwave that I used for this study. This is the fume mode. And this is the ICP, inductive coupled plasma atomic emission spectrometer. And this table shows the wavelengths used in the measurement of microelements. And this table shows the use in measurement of macroelements. A total of 7 micro and 5 macro elements were analyzed for this study, and those are copper, cadmium, chromium, iron, manganese, lead, and zinc as microelements, magnesium, phosphorus, calcium, sodium, and potassium for the macroelements. This table shows the results considering the microelements composition in liver of male and female cow nose ray liver. The results show that there are no or below the detection level of chromium in the liver of male and female race in this current study. The levels of lead, heavy metal, which is a heavy metal in the liver of the male and female race in this study differed from each other, and this differentiation were found to be statistically significant. The levels of cadmium, which is another heavy metal, in the liver of the male tend to be higher than that of cadmium in the liver of the female. Even though there is a certain differences between male and female livers in race regarding its accumulation of cadmium, no statistical significance were observed between them. Based on the data obtained from this work, the accumulation of elements in liver of the male and female, pardon. Bana mı bir şey dediniz Didem hocam? Şey yapamadım. Okay. Based on the data obtained from this work, the accumulation of the elements in livers of male and female race differ from each other. The results also show that accumulation of microelements. Is there any?
Okay, o number so.
Birinin sesi açık.
Okay. They can leave room.
The results show that accumulation of some microelements, such as the levels of cadmium, copper, iron, and lead, higher than those of other elements measured in this current study. The levels of mangan in male and female cow nose race was calculated to be close to each other. The levels of zinc in female cow nose race was found to be higher than that of male cow nose. Based on the data, in the liver, males tend to accumulate elements than those in females. They have different amount of microelement levels. These differentiations were found to be statistically insignificant except the levels of lead. Yilmaz et al. Reported that element concentration generally may depend on different external factors such as temperature, light, oxygen, and nutrients, and the physicochemical parameters such as pH, salinity in organic and organic complex molecules. They may be affected on metabolic activities, and the level of elements may change according to species. This study shows that it is also depend on whether it is male or female. There could be a gender differentiation. And maximum advisable cadmium level for fish is generated 0.05 milligram per kilogram European Commission Regulation 2001. According to the Institute of Turkish Standards, tolerance levels of cadmium in food should not exceed 0.1 milligram in kilogram. In this case, with this study, raw material should be handled with careful consideration. One should keep in mind the recommendation levels and how much the raw materials have, and decide what to do with per serving. And this table shows the macro elements composition of male and female Kaunos ray liver. And there are differences in male and female Kaunos ray regarding their macro elements. At the same time, there are differences in males as well as females. The levels of calcium in female Kaunos ray show the differences itself. However, in general, they are in reach in regarding their macro elements. In conclusion, accumulation of cadmium, chromium, copper, iron, manganese, lead, and zinc in liver of male and female Kaunos ray were investigated in this study. The results show that microelement accumulation in liver of male and female Kaunos ray differed. Also, livers of male and female Kaunos ray are rich in macroelements, magnesium, phosphorus, calcium, sodium, and potassium. But also further studies are needed on this subject to prove this fact. Thank you for joining and listening. Any questions?
Yes, thank you for your speech. Have you got any questions to dear Özge Yılmaz? I think no questions. Yes, thank you, dear Özge Yılmaz. It's turn. Yes, it's turn to This is Pekel. Yes, it's turn.
Sorry. Hello, everyone. I'm hello, I'm Özgen. I'm associate professor at Ankara University. Today, I want to make you a short presentation about aryl-aryl coupling. First, I'd like to give you some literature information about aryl-aryl coupling. Then I will look at organizing regions and our previous studies in this topic. And finally, I will present our findings on aryl-aryl coupling. Ketones are important building blocks in several natural and pharmaceutical products. For the synthesis of ketones, the coupling of acyl halides with organometallic reagent overcomes some drawback of Friedel-Crafts acylation. So far, many methods have been developed for the acylation of Grignard, organocopper, and organozinc compounds. These methods have some restriction, such as the formation of side products, including paired alcohol, and the problem of the functional group arises. However, organozinc reagents are good partners for acylation due to their high tolerance to functional groups and not the formation of side products. Diorganizing reagents are reactive than organizing halides. However, in the reaction of diorganizings, only one group is transferred to an electrophile. The other organic group is vesting. To avoid vesting organyl groups, mixed organizing reagents have been developed. Mixed organizings compose of one transferable group together with a residual or dummy group. Generally, methyl, terpidyl, trimethylsilyl, neopentyl, and neophyl group acts as excellent residual group. To prepare of mixed diorganizing reagent, firstly, aryl magnesium bromide is prepared and the concentration of Grignard reagent is founded. Then transmethylation of aryl zinc halides were quantitables with zinc halides. Then alkyl magnesium bromide is added to, at -20 degrees. So far, mixed diorganizings have been successfully used in carbon-carbon coupling and addition reactions. In our previous studies have been found that alkyl or aryl group transfer ability are solvent-dependent. Namely, we succeed in controlling alkyl or aryl group transfer by using cosolvent. When N-methyl-2-prolidin or dimethylene dimethyl ether was used, the alkyl group was transferred selectively, but the aryl group was transferred when tetramethylene diamine was used. In our previous studies too, we have found that the relativity ability of organyl groups in mixed diorganizings can be controlled by using catalysts. Can be seen from scheme. Selective alkyl group transfer takes place in the presence of phosphine catalyst, whereas in the presence of nickel oxide, aryl group transfer takes place. But these methods have some disadvantages. Phosphines are unsettable in air and nickel catalysts are expensive than iron catalysts. In this research, we plan to develop a new atom economic protocol for aryl-aryl coupling using low-cost, easily available, and non-toxic iron catalyst. Based on our previous experience, first we decided to screen the suitability of iron catalyst in the aryl-aryl coupling. We chose reaction of butyl phenyl zinc with benzoyl chloride in THF as a model reaction. As iron catalyst, iron 2 chlorides, iron 3 chlorides, iron 2 acetate, and iron 2 acetylacetonate. As can be seen from table, all iron catalysts are not successful in group selective coupling. The best iron catalyst for aryl-aryl coupling seem to be iron 3 chloride or iron 2 acetate. Before deciding between iron 3 chloride and iron 2 acetate, as the most active catalyst, we investigated the effect of cosolvent or additive. However, the use of cosolvent gave quite low yields. The addition of lithium chloride did not make a change in the yield and phenyl selectivity in the presence of iron 3 chlorides. But in the presence of iron 2 acetate, using lithium chloride as an additive, lowered the yield. However, it did not change the phenyl selectivity. For deciding between iron 3 chloride and iron 2 acetate, we compared the atom economic utility acylation yields of homodiorganizing regions. In the presence of iron 3 chloride, we observed that the sum yields for homo and mixed diorganizing. In the presence of iron 2 acetate, the higher acylation yield of phenyl group in mixed zinc was found than that in homozinc regions. We also evaluated the metal group as a residual group instead of butyl group, and we observed the higher phenyl selectivity. So we chose iron 3 chloride as iron catalyst for aryl coupling. These rules provides a new simple and atom economic metal catalyzed acylation of homodiorganizings. And iron catalyzed are inexpensive and non-toxic, so this procedure is a supplement to nickel catalyzed acylation of mixed diorganizing. And finally, this route is an efficient method for the synthesis of diaryl ketones. Thank you all for listening to me. Thank you for your attention.
Thank you for your speech. Have you got any
questions
to dear Peker? I think no question. Okay, thank you. Yes, it is my turn.
Thank you. Mrs. Kahya, your voice is closed.
Yes. I introduced myself in the beginning of section, so I want to go directly to my presentation. I'm going to talk about chemoselectivity in copper-1 catalyzed electrophilic amination of phenylmagnesium bromide with 3-methylsilyl hydroxylamine. Amines are of much importance to the amino functionality in natural products and pharmaceutical compounds, as well as building blocks in organic synthesis. Modern methods are now available to form and using transition to form carbon-nitrogen bonds and using transition metal catalyzed amination of carbon halogen bonds or carbon hydrogen bonds provide important methodologies for the synthesis of arylamines and heteroarylamines. These methods are known nucleophilic amination. Electrophilic amination of organometallic compounds, that is coupling of carbanions with electrophilic amination regions, which are synthetic equivalents of electrophilic nitrogen, is also an important and potentially valuable methodology for the synthesis of amines. Electrophilic amination regions contain either sp3 nitrogen and sp2 nitrogen. For example, N-chloramine N-O-substitute hydroxylamine react with carbanions directly. O-sulfonyl oxime and iron diazoine salts form intermediates which require reductive workup to produce anodes. Over the last 20 years, our research group has been involved in electrophilic amination of green regions, the organocuprates, the organozincs, and 3-organozincates with O-methyl hydroxylamine, with N,N-dimethyl O-methylene sulfonyl hydroxylamine, and with acetone O-methylene sulfonyl oxime. However, to the best of our knowledge, NO-bis 3-methylcyclic hydroxylamine and N-alkyl or 3-methylcyclic hydroxylamines did not receive much attention. They have been used only for high-yield amination of aryl and heteroaryl Lipschutz type cuprates. The alkyl cyanocuprate by Ritchie and co-workers, and ferrocene carbophyrdite could be also aminated following alpha-lithiation and reaction of palladium mixed cyanocuprate with 3-methylcyclic hydroxylamine. In the amination of the alkyl cyanocuprates and mixed alkyl phenyl cyanocuprates, both alkylamine and alkanol formation has been observed and resulted in carbon-nitrogen and carbon-oxygen coupling. So, encouraged by these results and essentially in an effort to broaden the scope of electrophilic amination, we focused our interest on the investigation of the utility of 3-methylcyclic hydroxylamine for amination of aryl guanyl regions in the presence of copper-1 catalysts. We plan to develop a new method for arylamine synthesis using aryl guanyl regions dried catalytic cuprate instead of prepared higher order diaryl cyanocuprates. On the other hand, while we are optimizing the reaction parameters for high yield carbon-nitrogen coupling leading to arylamine synthesis, we observe that carbon-oxygen coupling also takes place leading to phenol synthesis due to the nitronate and oxygenate equilibrium of the aminating reagent 3-methylcyclic hydroxylamine. These results prompted us to control the chemoselectivity in the reaction for allowing the formation of either arylamine and phenol. Resultant discussion. In the amination of copper-1 catalyzed guanyl regions with NO-bis 3-methylcyclic hydroxylamine, we began our investigations by determining the background yield. Guanyl regions for this purpose, as model reaction, we selected reaction of magnesium bromide and reaction of copper-1 catalyzed magnesium bromide with 3-methylcyclic hydroxylamine in THA. In table 1, the uncatalyzed reaction of magnesium bromide were carried out in THA and in THA and co-solvent with 2:1 and 3:1 mole ratios of magnesium bromide to 3-methylcyclic hydroxylamine. The total yield and carbon-nitrogen coupling ratio, carbon-oxygen coupling ratio were listed in table 1. So both carbon-nitrogen and carbon-oxygen coupling reactions might be expected to take place with 3-methylcyclic hydroxylamine in the presence of 2:1 and higher mole ratios of magnesium bromide and 3-methylcyclic hydroxylamine ratio. Surprisingly, we observed only phenol in THA with 56 and 35% yield in 2:1 and 3:1 mole ratio of phenylmagnesium and 3-methylsinyl hydroxylamine ratio. Donor solvents, monodentate HMPA and bidentate PMADA, were also tested as coordinating solvents in THF. As seen, carbon-nitrogen coupling didn't take place and the yield decreased in the presence of coordinating solvents. Next, we turned our attention to the elimination of phenylmagnesium bromide with 3-methylhydroxylamine in the presence of copper iodide or copper cyanide as catalyzed. Catalytic organocuprate and cyanophenoylcuprate and also phenylmagnesium bromide might deprotonate 3-methylhydroxylamine to form nitronate and oxenoate. We carry out the experiments at 2:1 and 3:1 mole ratio of phenylmagnesium bromide and 3-methylhydroxylamine ratio. Yes, in table 2, first we use phenylmagnesium bromide with between 10 and 14 mole% Bakr iodide or Bakr cyanide catalysis in the presence of 2:1 mole ratio of phenylmagnesium bromide and 3-methylhydroxylamine ratio. 10 mole% copper iodide catalysis in THF didn't result in a higher yield and aniline and phenol ratio. Surprisingly, in THF HMPA, the reaction gives aniline with an aniline and phenol ratio higher than 93 and 7 ratio. However, the total yield is pretty low, 54 and 45%. Better results were obtained when using 20 mole% copper iodide, both in THF and also in THF HMPA. THF led to 55% yield. We were delighted to find that the reaction in THF HMPA ratio 1:1 takes place with 83% yield and aniline and phenol ratio of 95 and 5 ratio. These optimized conditions seemed us as an atom economic alternative to electrophilic amination. The aryl cuprates with 3-methylhydroxylamine as a co-solvent TMHDA gave quite low yields. The effect of copper-1 catalysis was also examined for the reaction carried out with a 3:1 ratio. 10 mole% copper iodide catalysis gave between 16 and 58% yields with quite high aniline and phenol ratio in THF and in THF co-solvent. The use of 20 mole% copper iodide increased the total yield in THF and in THF HMPA, generating aniline with 18% yield in THF HMPA ratio 1:1. Meanwhile, 14 mole% copper iodide catalyzed reaction was completed with a quantitative yield and 73 and 76 yield of aniline in THF HMPA ratio 4:1 and 1:1 respectively. Copper cyanide catalysis also resulted in high yield and high aniline and phenol ratio in THF and co-solvent. The yields of anilines were found to be 84% in THF and PMEDA ratio 4:1 The one-pot procedure for amination of catalytic diaryl cuprate and aryl cyanocuprate was also carried out with 4:1 mole ratio of phenyl magnesium bromide and 3-methyl hydroxylamine in order to see a probable comparative change in the outcome of the reactions. Focusing to the atom economic synthesis of aniline, the total yield and chemoselectivities of the reactions with 2:1 and 4:1 mole ratio resulting more than 68 yields are listed in table 4. In this mechanism, carbanion of Grignard reagent and with 2-DHF coordination complex attacks electrophilic nitrogen of nitronoid, leading to an SN2-like transition state to give the product which offers the amine after hydrolysis. Similarly, attack of Grignard reagents with double DHF, the coordination complex, to electrophilic oxygen of oxanoid might form another SN2-like transition state to give the product which offers the phenol after hydrolysis. Reaction of phenyl magnesium bromide with 3-methyl hydroxylamine in THF and THF co-solvent generated only phenol as product. We also found that catalytic diphenyl cuprate and phenyl cyanocuprate derived from phenyl magnesium bromide are successfully in carbon-nitrogen coupling, resulting in high yields of aniline. Before offering mechanism for carbon-nitrogen and carbon-oxygen coupling of catalytic diphenyl cuprate, diaryl diphenyl cuprate and phenyl cyanocuprate, we first preferred propulsive transition states. We would propose that in the reaction of diaryl diphenyl cuprate with 3-methyl hydroxylamine, oxidative addition takes place either to electrophilic nitrogen or electrophilic oxygen, forming to the transition state 3 and transition state 4. Yes, the conclusion, with the aim of developing a new method for synthesis of alanine using electrophilic amination of Grignard reagents with 3-methyl hydroxylamine. First of all, we have demonstrated that reaction of phenyl magnesium bromide with 3-methyl hydroxylamine in the presence of between 10 to 20 mole percent copper iodide or copper cyanide catalysis in THF co-solvent at room temperature gives medium to high yields of aniline. This one-pot procedure can provide an atom economic and step economic access for aryl amine synthesis starting from aryl Grignard reagents. Second one, chemoselectivity in the reaction of phenyl magnesium bromide with 3-methyl hydroxylamine to give carbon-nitrogen or carbon-oxygen coupling can be controlled by changing reaction parameters. Carbon-1 catalyzes reaction of phenyl magnesium bromide in THF, HMPA, or PMEDA affords both carbon-nitrogen and carbon-oxygen coupling, whereas uncatalyzed phenyl magnesium bromide gives carbon-oxygen coupling, yielding phenol. It's obvious that 3-methyl hydroxylamine is a workable substrate for amination of catalytic diaryl cuprate and aryl cyanocuprate. Third one, mechanisms are proposed for the solvent dependence of chemoselectivity in the coupling of both uncatalyzed and copper-1 catalyzed Grignard reagents with 3-methyl hydroxylamine. And the last one, application of remarkable ability of copper-1 catalyzed phenyl magnesium bromide for carbon-nitrogen coupling with 3-methyl hydroxylamine to other aryl Grignard reagents are in progress. Thank you for attention and listening. This photo belongs to Ankara University Science Faculty. Yes, thank you very much. Have you got any questions? I think no question. Yes, it's your turn. Mr. Guernov. Yes, please.
Yes, Professor.
Yes, Guernov, it's your turn. Please. Okay.
Dear Professor and students, good morning. I am Abdelkader Garraf, a PhD student in the Faculty of Science in Oujda, Morocco. I have the pleasure to present to you a brief result about a large study concerning the characterization of polypyrrole using surface-enhanced Raman scattering. The spectrum detected on a Raman spectrograph consists of a very intense Rayleigh line, Stokes line, which are the Raman line, and anti-Stokes line. When the excitation frequency coincides with that of an electronical transition of a molecule, an intensification of some line of the spectrum is observed. This is called the Raman resonance effect. This effect presents some some inconvenience, such as the fluorescence emission, which mask the Raman line and limit the large utilization of this technique. On the other hand, and unlike platinum, metals such as silver, gold, or less frequently copper present an absorption band on the visible. So if a molecule adsorbed on the surface of one of these metals and excited with a wavelength that is the same as this band, a huge intensification of the Raman line will be observed, and the enhancement factor can reach a value of 10 in the power of 8. This is the Serres effect. This phenomenon has two origins, electromagnetic and molecular, and can make the possible detection of trace or even single molecule in complex environments such as biological media. In our study, the Serres analysis concerns two different materials. The first one is polypyrrole electrochemically synthesized on previously roughened silver electrode, and the second is a photochemical approach of polypyrrole using silver nitrate on copper plate, leading to silver fractal crystal. In the first method, before the electrode deposition step, a preliminary roughening procedure is applied to the electrode. The silver surface is polished and introduced into an electrochemical cell containing potassium chloride aqueous solution in order to achieve 3 potential swap between -0.4 and 0.2 volt. The SEM images after the activation process reveal the presence of asperities in the form of spheroid bonded to each other to form rod that themselves form connection in a coral-like structure whose distribution is uniform over the entire surface of the electrode. The second step is the electrodeposition of polypyrrole on the previously activated silver electrode using the galvanostatic mode. The preparation of the polymer was achieved in the well-known three-electrode system with a solution of dichlorometal. By applying different current density, we found that a value of 0.5 is the best one that led to the formation of homogeneous and very adherent polypyrrole without exceeding the oxidation potential of the monomer, which is in this case 0.8 volt. The obtained film is electroactive, and its electroactivity photometer is characterized by a couple of well-defined redox peaks. In the second method, a photochemical approach was realized based on an in-situ oxidation of polypyrrole using silver nitrate and UV irradiation on copper plate. An electronic transfer occurred between the monomer and silver cation lead to the formation of polypyrrole and metallic silver at the same time. The topography of the electrode surface revealed the growth of silver by repetition of the same pin leaves from form given a fractal geometry, as we can see here. The characterization of polypyrrole silver composite was achieved with X-ray photoelectron spectroscopy. Carbon XPS signal contained 4 Gaussian components. The main peak at 285 electron volt attributed to carbon atom of the pyrrole ring at position alpha and alpha prime. Knowing that pyrrole cycle has 2 types of carbon, thus the peak at 284.1 is electron volt is assigned to carbon beta, and the peak at 286.44 electron volt is attributed to C beta OH bond resulted from the presence of water. And finally, the peak at 288 electron volt arises from carbonyl group due to the unavoidable oxygen of contamination. The XPS spectrum of nitrogen contains 2 regions. The first is nitrogen atom of the pyrrole, the main band at 399 electron volt associated to neutral nitrogen, and the one at 400 electron volt to positively charged nitrogen, and the peak at 397 assigned to C-double-N structural defect. The second region is the nitrogen belonging to the neutral doping anion at 460.5 electron volt. The polymer doping rate can be calculated by the intensity ratio of N nitrogen doping agent and nitrogen polymer. It's 29% in our case, which is near the theoretical value of 33%. On the other hand, the interaction between the polymer and silver particle was confirmed by the presence of 2 doublets consisting of 2 sharp peaks associated with silver at 0 oxidation state. Ex situ Raman spectra of polypyrrole film covering platinum and roughened silver electrode is presented in this figure. As shown, the spectrum recorded in the case of silver is more intense with better resolved peak. The Serres enhancement factor was evaluated at 100 in this case. Moreover, and thanks to the Serres effect, other vibrational modes inactive on platinum are visible on the spectrum obtained on silver. The main band at 1610 cm-1 is assigned to CCC ring stretching. As known, the transition between the reduced and oxidized state of polypyrrole is accompanied by the transformation of some ring from aromatic to the quinoid structure. And according to some other, the frequency of the CCC vibration in the quinoid nuclei is higher than that of aromatic. Therefore, in our case, this band is shifted toward high frequency in the case of polypyrrole silver system, so the polymer deposited on silver contain more quinoid nuclei and will be more oxidized than the elaborated on platinum. The intensity ratio of 2 bands that form the doublet of C single bond IH implying deformation reflect the oxidation state of the polymer. Some others stated that when the oxidation degree decreased, the intensity of the peak located at higher wave number side of the doublet decreased and almost disappeared. In our case, by comparing the intensity of these 2 bands in the spectra of the 2 systems, it appears that the film elaborated on roughened silver is more oxidized than that on platinum. In addition, 2 bands are particularly affected by the effect of the intensity enhancement. The band at 937 cm-1 attributed to C beta H, and the one at 1418 cm-1 assigned to C alpha N. According to the Serres selection rules that said that the most enhanced modes are those involving a significant variation of the alpha ZZ components along the OZ axis normal to the surface of the Serres active substrate of the polarizability tensor during their vibration, we can conclude that the polypyrrole chain are oriented so that the C beta H and C alpha N bond form almost a right angle with the metal surface. So the parallel ring will be nearly in standing position since they belong to the same plane as this bond. The same spectrum of polypyrrole obtained photochemically with the deposition of silver on a copper plate is presented in this figure. In this case, the enhancement factor reached 200 instead of 100 for the first case. This huge exaltation is due to the fractal nature of the analyzed surface, according to some published work. All the peaks are highly resolved, and the massive observed at 130,000 centimeters minus 1. In the case of polypyrrole platinum and polypyrrole silver, appear to consist of 4 highly visible components in this case, and the decomposition of this spectral region was impossible to perform because of the overlapping of this 4 Raman band in a relatively low resolution signal. The band associated with CCC bond split into its 2 components at 1526 cm minus 1 and 1620 cm minus 1 attributed to aromatic and quinoid structure, and in addition the CCC line is shifted toward the high frequency and it is more intense than CCC aromatic line, so the polymer has a high oxidation degree. As conclusion, the electropolymerization of pyrrole on roughened silver electrode has led to an important amplification of the Raman intensity, whose enhancement factor reached 100 in comparison with the resonance Raman spectrum of polypyrrole obtained in the same condition on platinum. According to the Serre's selection rule, the intensification of the CH and CN mode suggests that the nuclei of the polymer are perpendicular to the surface of the electrode. The importance of the fractal behavior of the surface in the observation of the Serre's effect is dramatically confirmed by the analysis of polymer with a fractal distribution of silver crystal photochemically obtained on a copper plate. And finally, the fractal leaf-shaped silver matrix exhibited significantly higher enhancement of the Raman intensity compared to the roughened silver plate because of the high amount of hot spots. And thank you for your attention.
Thank you for your speech. Have you got any question to Mr. Guerra? Yes, thank you. Yes, it's
Thank you,
your,
Professor. Thank you.
Yes, thank you. Okay. It's your turn, Mr. Moden. Mr. Moden, I think. Yes. Open your camera, please. Yes, thank you.
Hello?
Yes. Hello. Let's go, please.
Abdelaziz Muddin, PhD student of University Ibn Agadir. I'm happy today to be with you in this Asian International Conference of Energy, Natural and Medical Science. I have the honor to be today with you for share of experience and knowledge in the field, and I want to thank the committee members for organizing effort and also all participants. So my topic today is the valorization of raw biomaterial waste lead stone as an efficient absorption of copper, lead, and zinc ions. The plan is like the following. I want to start by introduction general of pollution. After that, preparation of raw date stone and adsorption result. This is the first result. Characterization is not yet ready, and finally conclusion. Introduction. In recent years, several hazardous pollution are increasing being detected in aquatic environments. One of these pollution, heavy metal and organic dye that is not biodegradable and dangerous for our planet and for human health. So, the presence of heavy metal and chlorine metal in textile and pesticide discharges can pose a serious threat problem for environments. So, without prior treatment, this is a big problem. So, treatment will be therefore essential to eliminate this environmentally harmful material. In general, we have four procedures to eliminate or depollution of industrial and organic agriculture waters. Electrodegradation, this is the first one. Second one, coagulation, flocculation, and photocatalysis, and finally adsorption. In my work, I'm interested by adsorption procedure is a surface phenomenon by which gas or liquid molecular attached to the solid surface or adsorbents. The adsorbed molecular constituent the adsorbate. And also, this adsorption phenomenon is a good probability and sample to hand and shapers. As we know, the presence of heavy metal in water, even in trace amounts, is an environmentally hazardous. There is imperative need to develop innovative and environmentally friendly material for their removal from wastewater. The present study is concerned with the valorization of datestone for the wastewater treatment. Datestone as adsorbents were tested for adsorption of copper, lead, and zinc from aqueous solution. The effect of different parameters to adsorption of metals such as contact time, the initial concentration, and the pH of solution were investigated, showing an efficient adsorption exceeding 95% toward copper, lead, and zinc when their concentration was lower than 10 ppm, and the from 60 to 94 a metal concentration higher than 10 ppm. So the experience showed that the copper and lead had higher adsorption capacity for zinc, and the concentration of copper and zinc and lead were determined by AS, flame spectroscopy absorption atomic. The raw datestone selected in this work were collected from locality of south of Morocco. The preparation is wash this raw datestone with distilled water to completely free from dirt, then dry with 105 degrees for 24 hours. After that, crush to obtain a powder of red size between 200 and 300 micrometer. The chemical for copper, I'm using the copper sulfate, and for lead, the lead chloride, and for zinc chloride. All batch adsorption experiments were investigated and constant speed and temperature of 25 degrees and adsorbance dose 1 gram per liter. The adsorption copper, zinc, and lead ion was studied in pH from 2 to 12. For adsorption application, I'm study effect of initial pH of the adsorption of copper, lead, and zinc. The experiments I'm using 200 milligram of powder with 200 milliliter of solution with different concentration 5, 10, and 15 ppm of different heavy metal, copper, lead, and zinc. In this experiment, the initial pH of solution containing a solute was adjusted to the desired value from 2 to 12 pH. The effect of pH on the percentage removal on the solute is shown in the figure. We have three figures for different concentration, 5 and 10 and 15. The figure shows the maximum percentage removal of the lead and copper and zinc from aqueous solution. At 5.5, the maximum of pH is from 5.5 to 6. And that percentage of separation decrease with decrease in pH. And the percentage removal of lead and copper decrease also with further increase in pH. So optimum is from 5.5 to 6. The change in pH can affect the adsorption surface load, the degree of ionization and speciation of metal adsorbate, as the surface load density decreases with increase in pH of the solution. One, the optimal pH range usually between 5.5 to 6. Effect of initial concentration. The adsorption capacity of copper, lead, and zinc ion based on initial concentration is shown in the figure like the following. An initial metal concentration of 5 ppm result in increase in adsorption capacity from 97 to 99 for all metal ion, as the figure shows. At higher concentration, maximum adsorption was 98 for copper and 99 for lead and 97 for zinc, corresponding to the saturation of activated state on the adsorbents. An increase in metal suppression may be due to an increase in electrostatic interaction involving state of progressively low affinity of metal ion. And in conclusion, the raw dates to use to remove copper, lead, and zinc from ion aqueous solution. It's have a big capacity or high capacity at pH from 5.5 to 6 pH, and is show the date raw shows the date raw stone has affinity adsorbance for the removal of heavy metal from aqueous solution. And thank you for attention. Thank you very much.
Yes, thank you for your speech. Have you got any question to Mr. Moden? Yes, I think no questions. Yes, thank you very much again. It's your turn, Mr. Kitabi. Are you ready?
Yes, ma'am, I'm ready.
Yes, okay. It's your turn. Welcome.
Okay, thank you.
Never mind.
Good morning, ladies and gentlemen. On behalf of my team, allow me to extend a warm welcome to you. Let me briefly introduce myself. My name is Khalil Khattabi, and I am a PhD student from Morocco. And I have the pleasure of participating in this event, ELVED International Conference on Mathematics, Engineering, Natural and Medical Science in Karak, Jordan. I'm delighted to be here among you today to talk about Alzheimer's disease and computational chemistry. Before starting, I will first present the title to you as well as the different parts that we will see together in the presentation phase. So as you see, I titled it Discovery of Novel Potential Anti-Alzheimer Hydrazones Derivatives Using 3D Quasar and Molecular Documents. I choose to work on that theme because it's a very important subject on the pharmaceutical field. So I will talk about a few things that will interest you. To do that, we will follow a plan starting with an introduction, materials and methods. We're gonna discuss the results, and finally conclusion and prospects. So Alzheimer's disease is a progressive neurodegenerative disorder characterized by loss of cognition and impaired intellectual ability and functionality. Alzheimer's disease is a curious and alarming situation and an increasing issue across all nations, mostly affecting the older population. Alzheimer's disease typically causes a complete deterioration in memory abilities and mental activities, leading to the most common form of senile dementia and affecting many people with dementia worldwide with an increasing tendency. Many etiologic mechanisms, including metabolic, genetic, environmental, and lifestyle factors, are key pathological features in the appearance and progression of the disease. So for the causes, abnormal breakdown, buildup of amyloid beta deposits, damaged amyloid proteins built to toxic levels causing cell damage and death, caused by to protein abnormalities caused by reduced synthesis of acetylcholine. Destruction of these neurons causes disruption in distant neural networks, perception, memories, and judgments. For the symptom, we find memory loss for recent events, changes in personality, getting lost or misplacing belonging, require daily assistance, experience even greater memory loss. So I'm gonna give you some statistics about Alzheimer's disease in the whole world. So for the World Health Organization estimated that in 25, 0.379% of people worldwide had dementia, and the prevalence would increase to 0.556% in 2030. For our continent, especially for sub-Saharan Africa, an estimated 2.13 million people were living with dementia in sub-Saharan Africa in 2050, with numbers projected to nearly double every 20 years, increasing to 3.48 million by 2030. Actually, there is no finally targeted and anti-Alzheimer agent able to treat this disease at present. There are several drug targets which are reported to control the severe level of Alzheimer's disease, among which acetylcholinesterase enzyme is approached as a good drug target for this disease. Hence, the present study mainly focused to discover newly benzimidazole derivatives as potential acetylcholinesterase inhibitors drug through several computational approaches. So we have raised the following question: why using computational chemistry? The response is simple. It's for economize laboratory waste, reduce the waste of biological tests and the waste of clinical tests, saving the expenses of the pharmaceutical industries. For materials and methods, the computational techniques that we use, usually there are many. There are 3D Quasar, molecular docking, molecular dynamic simulation, math, virtual screening. But for this study, we have performed two techniques: 3D Quasar through CONFA and COMSIA methods, molecular docking through the Surflex docking method. For the 3D Quasar technique, this technique aims to study the relationship between structure and the activity quantitatively. And for the molecular docking, this technique is a powerful approach which aims to predict the optimized binding conformation of a ligand and understand the receptor-ligand structural interactions. So this is, as you see here, this is the chemical structure of the studied compound. These compounds were synthesized and evaluated for acetylcholinesterase inhibitory activity. These compounds were from a published article. So we have performed 3D Quasar on these compounds, on these derivatives, and we have generated contour maps for CONFA and for COMSIA. For CONFA, there is steric field and electrostatic field, and for COMSIA, we have three more: H bond acceptor field, H bond donor field, and hydrophobic field. So from this contour, we can add or eliminate or remove substituents in order to increase the activity. So here, the newly designed compound have a reliable relationship between the electrostatic and hydrophobic effects and the acetylcholinesterase inhibitory potency. These findings provide valuable insights for the rational development of new acetylcholinesterase inhibitors with enhanced activity based on these derivatives. So as a result, we have designed 5 molecules, as you see here, with different substitutions at different places. So the newly predicted activity values showed effective inhibition of Alzheimer than the most compound, which is number 19 for the generated models as depicted in the table. So as you see here in the table, the newly designed compounds have the inhibitor activity much greater than the compound, which is the most active compound. For the results of molecular docking, these interactions are the main factor having an important impact on the affinity of a ligand to their receptor, which match well with the result of hydrophobic and electrostatic contour map supporting the selected pose of the proposed compound E1, which could form a strong inhibitor effect on acetylcholinesterase, as you see, for the newly designed compound, which have more favorable interaction than that of the most active compound. So let's summarize briefly what we have looked at through this figure. In the current study, a combination of 3D quasar and the molecular docking was used to explore the relationship between structure and activity for a series of selective benzimidazole derivatives as potent acetylcholinesterase inhibitors. The optimal models were validated internally and externally as demonstrated by the statistical criteria. The 3D quasar contour maps analysis helped to better interpret the future requirements, revealing the crucial role played by the electrostatic and the hydrophobic substituent to increase inhibitory potency. As a result, 5 new compounds were designed in silico. These findings provide valuable insights for the rational development of new acetylcholinesterase inhibitors with enhanced activity based on benzimidazole derivatives. So overall, this work could provide valuable information that could be applied to the design of novel acetylcholinesterase inhibitors for further drug discovery research. The proposed molecules, and in particular, the molecule E1 with higher inhibitory activity and total score, showed more promising results as a potential inhibitor capable of stopping Alzheimer's disease. Computational chemistry is a very important field of research, and it's innovative phase that can guide the synthesis of drugs. And thank you very much for your attendance.
Yes, thank you for your speech. Have you got any question to Mr. Kitabi?
I would like to say something.
Yes, please.
First of all, congratulations. It's a good topic, and I think it needs many studies on this field. And I wish you luck in this field for further studies. That's all I want to say.
Thank you. Thank you, ma'am.
Thank you. It's your turn to, I think, Mr. Calden. Yes, it's your turn. Mr. Calden. Are you Calden? Yes. You got any problem?
Hocam,
Yes.
var mı üçüncü şey? Katılımcımız.
Ayıp kaldım olacak ama buradaydı sanki.
Sesi kapalı olmuş olabilir, yani sizi duyamıyor olabilir.
Yes, yes. Hello. Is your problem?
Yes, teacher. No.
Yes, okay. It's your turn, please.
Can I start my presentation? Teacher?
Yes, Alison.
Can I start my presentation?
Yes, okay. Lütfen, please.
Yes. Hello, everyone. My name is Ayoub Khaldan. I'm from Morocco. I am PhD in traders. My field of research is molecular modeling, and I am very happy to be with you. So before starting this oral communication, first of all, I would like to take the opportunity to thank the scientific committee of 11 International Conference on Mathematics, Engineering, Natural and Medical Science. So the oral communication that I will present to you today concern discovery of potent benzotiazole as alpha-glucosidase inhibitors through 3D quasar molecular docking simulation and ADMET screening. This work is supervised by the Professor Abdelwahid Sbai, Professor Taher Al-Khalifi, and Professor Mohammed Bouachri, and presented by myself. So, to put you in the context of this work, allow me to present the outline of this work. We start with an introduction and the biological activity, then the methodology used in this work. After we discuss the essence of the results obtained, and finally the conclusions and perspective envisaged for this work. In the area of drug discovery and environmental risk assessment of chemicals, knowledge of activity is of paramount importance in order to classify and use these chemicals. The experiment is a direct means of obtaining data on the activity of chemical compound. On average, for 10,000 molecules that are synthesized and tested, only one arrive on the market as innovative drugs. In addition, the development of a drug requires between 10 and 15 years of research. Consequently, the time required as well as the availability of laboratory equipped for carrying out the synthesis and tests make this process difficult and expensive. Therefore, the use of alternative method to experiment has become more than essential. Among these methods are the Quasar method, which quantitatively links molecular property called descriptor with an experimental effect, either biological activity or toxicity or even physicochemical property, for a series of similar chemical compound, the general form of which is a flow biological activity according to descriptor. Now, let's move on to biological activity. Diabetes mellitus is a disease linked to a failure of the biological mechanism regulating blood sugar, that is, blood glucose concentration, leading to chronic hyperglycemia. There are two main types of diabetes. Type 1 diabetes, it is also called insulin-dependent diabetes or juvenile diabetes. In this case, the body does not produce insulin or insufficient quantity. This type of diabetes represents 5 to 50% of diabetes cases. Type 2 diabetes can account for about 90% to 95% of all diagnostic diabetes cases. It usually starts with insulin resistance, a disorder in which cells do not use insulin properly. In this case, the pancreas gradually loses its ability to make insulin. So, in order to treat type 2 diabetes and its complication, the inhibition of digestive enzyme like alpha-glucosidase is an effective approach that can reduce postprandial glucose and risk factor. Alpha-glucosidase, such as voglibose and acarbose, are clinically used for controlling the rapid increase of blood glucose. However, they often lead to some side effects, including diarrhea, abdominal pain, and other gastrointestinal disorder in chronic therapy. So, the search for efficient and safe alpha-glucosidase inhibitors are necessary for the therapy of postprandial hyperglycemia. For this purpose, we apply two computational techniques such as 3D Quasar and molecular docking on a series of 93 benzothioazole derivatives in order to predict new compound with high alpha-glucosidase inhibitor. Computational admits, that is absorption, distribution, metabolism, and exertion, and toxicity analysis was performed to assess the oral bioavailability and study toxicity of the newly proposed molecule. So, after this contextualization of our presentation, let's move on to presentation of the essential of the different methods and techniques that we used in this work. So, in 3D Quasar, the most representative method are the comparative analysis of molecular field and the comparative analysis of the molecular similarity index COMSIA. The CONFA method analyzes the field of interactions steric and electrostatic, while the COMSIA is an extension of CONFA, which use in addition to steric and electrostatic interactions field, lipophilic interactions, and hydrogen bond acceptor and donor fields. The molecular docking process consisting of placing the ligand in the active site of protein and sampling the possible conformation, position, and orientation. Let's move on to the result and discussion. So, natural and synthetic compound of the benzotiazole derivative family have shown a wide variety of biological activity, such as antimicrobial, anti-leishmanial, anti-cancerous, and anti-diabetic. For this work, we will be interested in the anti-diabetic activity. For this, we performed ACUSAR study on a series of 23 molecules of benzotiazole derivative in order to determine the quantitative relationship between this structure and alpha-glucosidase activity. The range of activity is between 4.43 and 6.40. So, before building a 3D ACUSAR, it is necessary to go through a method very important called minimization and alignment. The following table gives the observed and predicted activity value of benzotiazole derivative. So from this table, we notice that the difference between this value is very small, which indicating the high correlation between the observed activity and the predicted activity. The second table gives the statistical value of CONFA and COMSIA. As you see from this table, that the value of R square and Q square are greater than, are very important. The table shows also that the value of R square test of CONFA and COMSIA are greater than 0.66, which implies that our model has been well validated. From the figure 3, the good linear relationship showed that the activity predicted by the derived models agree with the experimental data, indicating that these models had satisfactory predicted power. The following figure shows the contour maps of CONFA, steric, and electrostatic. So from this figure, we notice that the green contour shows where huge groups are favorable, unlike the yellow contour. The blue contour shows the substitution of electron donating groups increasing activity, unlike the contour, the red contour. And the same explanation for COMSIA. So based on this, on all this contour map, we proposed and designed three newly molecules with more important activity than those of existing molecules. The molecular docking results show that the predicted compound X1 exhibits several and different interactions with the protein in comparison with compound H, which is the most active compound in the series, as well as compound X1 has a higher binding affinity value than that of molecule H, as shown in the following table. The following table shows that our proposed molecule respects Lipinski's rule of 5, and to ensure that the proposed molecules are viable drugs, we calculated the ADMET property. So from this table, we see that the three molecules have good absorption and distribution, and that molecule X2 and X3 exhibit no toxicity respecting the AMES test. Therefore, they can be easily synthesized. Conclusions. So, in this study, 3D ACUSAR and molecular docking method were used to investigate the relationship between alpha-glucosidase activity and the structure of benzotiazole derivative. The obtained results by the method are satisfactory. And the molecular docking predicted and evaluated the binding mode of the ligand inhibitor at the active site of protein. We succeeded to propose new molecule with important alpha glucosidase activity value, which confirms the originality of this work. And finally, the result of in silico admins exhibited the good property of bioavailability for the now suggested alpha glucosidase, especially the compound X2 respecting the Ames test and the drug-likensis rules, which lead to synthesis it easily. As a perspective of this work, perform the calculation with new methods such as 4D quasar and molecular dynamic simulation, and make the reactivity of the proposed molecule, that is cycloadditions reactions. And thank you for your attention.
Yes, thank you for your speech. Have you got any questions to Mr. Galdan? Yes, thank you again.
Thank you very much, dear teacher. Thank you very much.
Thank you. It's your turn, Miss Bob Dalloy. Yes, are you ready?
Yes, I'm ready.
Okay, thank you. Welcome to speech. Yes.
Do you hear me?
Yes, okay. It's yours.
I am Nimona Wabdlawi from Morocco. I am pleased to present to you our work entitled Electrochemical Deposition of Polytrophan and Titanium, Nickel, and Stainless Steel in Solution of Phosphoric and Perchloric Acid. Polytrophan and its derivatives are promising conductive polymer because of their remarkable properties. Thanks to these properties, polytrophan offers several possibilities for development of industrial application. However, polytrophan is generally sensitive in organic media because of the poor miscibility of trophan in aqueous media. In this context, this work will be devoted to the study of the electrochemization of trophan in solution of phosphoric and perchloric acid on oxidable metals. The electrochemical experiments were performed in one compartment cell using Origalis potentiostat. The working electrode was an oxidable metal disc. The auxiliary electrode was a stainless steel plate, and all potential were measured by saturate silver chlorine reference electrode. Trophan is quite unstable in strongly acidic solvent, and optical analyses indicate the formation of oligomers. The two steps of chemical formation of trophan, oligomers, and electrochemization can be schematized as follows. A preliminary study of electrochemical behaviors of the oxidable metals in the presence of the monomer reveal a passivation effect of the surface of the working electrode, and the first scan show a wave of oxidation of the metal followed by passivation. Similar electrochemical behaviors were observed in concentrate perchloric acid, and perchlorate anion could be involved in the passivation. Since the oxidation reaction of the metal is inhibited, The addition of the monomer to the acidified electrolytic media has led to the electrodeposition of polytryptophan. The growth of the current densities of anodic and cathodic peaks confirm the increase of the thicknesses of the polymer. The first scan reveal a primary stage of competition between the solution of the working electrode and electropolymerization. After the electropolymerization become propellant and lead to the formation of polytryptophan. The voltammogram then take a similar shape to that recorded on platinum and glassy carbon. By galvanostatic mode, different current densities were imposed to the electrode. The curve obtained vary according to the nature of the metal and the current density applied. In the both media obtained homogeneous polytryptophan film on the surface of the oxidable metals refused densities greater than that recorded on platinum. In potentiostatic mode, the electropolymerization is targeted only when the applied potential exceeds the oxidation potential of the monomer and depends on the nature of the metal. In two media, homogeneous film are obtained on all oxidable metals from 1 volt. In this section, structural and morphological characteristics of coating prepared and analyzed. The carbon spectra are decomposed into 4 components. After reduction, the peak kept the same position, but the value of the ratio of the entropy changed. The sulfur similar complex to the bluish are respectively due to the neutral and oxidized sulfur. The second doubly is more intense in the case of doped film because of the positive charge included in the backbone of the polymer by oxidation. The intensities of the various components of sulfur are insensitive to the nature of the metal, and the mode of electrosensitivity depend closely on the oxidation degree of the polymer. The spectra of the all sample sensitivity in phosphoric acid show a single doubly attributed to the anion doping. Dopage rates are approximately 20% in the oxidized state and 2% in the reduced state. For the polymer sensitivity in perchloric acid, 2 doubly are observed in the oxidized state. The first is assigned to the chlorine atom, and the second comes from the presence of the perchlorate anion. After reduction, this doubly disappear almost completely following the expression of the counter anion. Estimated doping rates are around 15 to 20% for oxidized films and between 0 and 1% for reduced samples. We have attempted the decomposition of oxygen massive with 3 forward peaks having several origins, doping anion, oxygen group, oxygen contamination, and residual water. Infrared analysis revealed the presence of the band characteristic of poly-2,5-tryptophan, and the degree of polymerization estimate from the relation of Furukawa is about 40. Scanning electron microscopy micrographs reflect the effect of the metal electrosensitivity technique and electrolytic medium on the morphology of the polymeric coating, and the different and varied morphologies are observed. In conclusion, we have reported in this work the electropolymerization of tryptophan in aqueous media. In the producer, we have described soluble oligomer of tryptophan are produced by chemical oligomerization. The preliminary study of the electrochemical behavior of oxidable metals in the absence of the monomer reveal a passivation effect of the surface of the working electrode. The addition of the monomer to the acidified electrolytic media has led to the electrodeposition of polytryptophan. Infrared analysis has proved that coupling mode in this film is of type 2,5 with a degree of polymerization approximately 40. Calculate Doppler rate is of the order of 20%. And surface analysis has demonstrated that the morphology of the polymer is closely dependent on the composition of electrolytic media, the nature of metal, and electrochemical sensitivity technique. The most homogeneous film are those sensitized at constant current density in perchloric acid. And in the end, thank you for your attention.
Yes, thank you for Mrs. Baudal-Haoui. Have you got any question to dear Baudal-Haoui? Have you got any question? I think there isn't any question. Okay, thank you again.
Thank you.
I think this was the last presentation. Is that right?
Yes, it's the last presentation.
So
It's your turn, Sokaina Bomran. Are you ready? Are you here? Yes, Sokaina Bomran. I think.
Hocam
Yes.
gözüküyor burada. Minovna.
Hello?
Yes. Okay. Your turn, Sokaina Bomran.
Hello?
Hello. Are you ready, Sokain? This is Sokain. Can you hear me?
Yes, yes.
Okay. I'll wait you.
Hello?
Hello.
Can you present my my work?
Yes, it's your turn. Please, you will start.
We have a problem of partage the écran.
Are you share screen? Do you share screen?
Teacher, I think that the already participants not yet stop her presentation.
No, I have stopped screen partage.
No, the last presentation. We have
a problem in the share of ekran. So
Yıldız Hocam ne yapabiliriz?
Hocam problemim var.
Sanırım ekran paylaşılamıyor.
Normal sunum yapabilir paylaşmadan.
Okay, teacher. Is good? Now is good?
Yes, it's good. It's ready, I think.
Slides clear?
Yes. Let's go.
I can't present my work?
There's no problem. I see the presentation.
Now is good, teacher?
Yes, it's good.
Yes.
Yes, please.
Hello?
Hello.
My name is Sokaina Bomran. I'm from Morocco. I'm studying in the second year PhD. Before beginning this oral communication, first of all, I take the opportunity to thank the committee of 11th International Conference of Mathematics, Engineering, Natural and Medical Science. This This oral presentation that I will be presenting today is on study of 3D quasar and molecular docking study of novel triazole derivative discovery of both antifungal drug. This work supervised by the Professor Hamid Maghat, Professor Mohamed Aziz Ajana, Professor Mohamed Bouchrine, and Professor Tal Khalifi, and presented by myself. To put you in the context of this work, let me outline the plan for this presentation. Start with the introduction and biological activity, then the methodology used in this work. Then we will discuss the main results obtained, and finally the conclusion and perspectives envisaged for this work. In chemical research field of drugs is very important because drugs are chemical compounds, so knowledge of the physicochemicals and the biological activity of these compounds is of paramount importance in order to able to classify and use them. In this study, we studied antifungal activity, so that antifungals are drugs capable of treating fungal and yeast infection that is fungi that can attack the skin, nails, and scalp. There are many types of fungal infections, such as Candida albicans, Aspergillus vaginatus, Cryptococcus neoformans, and Trichophyton rubrum. The first drug used as antifungal is amphotericin B. The only representative of the pollen family, its use is very often limited by the very frequent occurrence of potentially serious side effects, primarily renal failure, allergic manifestation, and hypokalemia. For the action mechanism, antifungal drug inhibit synthesis of the ergosterol in fungi cell. Ergosterol is essential compounds of the fungal membrane. The antifungal effects result from this inhibition, stopping the growth of fungi. The drug also used are compounds belonging to the imidazole family and are historically the first azote antifungals due to their poor digestive absorption and hepatotoxicity. Their use today is mainly done locally for superficial mycoses, mainly affecting the skin or mucous membrane. In recent years, new antifungal-based drugs such as fluconazole and itraconazole have appeared, and after the appearance of other drugs, voriconazole, posaconazole, and more recently isavuconazole have succeeded the imidazole. That's the chemical structure of the drug, of this drug. Then, for the development of a drug, it required a long time. Therefore, the use of alternative methods to experience has become more than indispensable. These methods include methods QSAR, which quantitatively link molecular property called descriptors with an experimental effects, the biological activity or toxicity or even physicochemical property for a series of similar chemical compounds. That is, in general, the study of biological activity according to descriptor. Let's move on to presentation of the essential of the different methods and techniques that we have used in this work. Introduce the QSAR. The most representative methods are the comparative molecular field analysis (COMFA) and comparative molecular similarity index analysis (COMSIA). The COMFA methods analyzes the interaction field, steric and electrostatic. The COMSIA is an extension of COMFA that use, in addition to steric and electrostatic interaction field, a lipophilic interaction field, a hydrogen binding acceptor field, and hydrogen binding donor field. To determine the predictive stability of the model, we have performed internal validation. In order to test the predictive capability of the Cursor model, we carry out the external validation. This validation characterized by the R-square test. The molecular docking process, placing the ligand in the active site of the protein and sampling possible conformations, positions, and the orientation. The scoring process evaluates the affinity between the ligand and the protein and gives a score to the proposed obtained during docking task. This score will make it possible to select the best pose among all those proposed. The result discussion with computational techniques such as 3D Quasar and molecular docking on a series of 29 reaction derivatives. We applied two computational techniques such as 3D Quasar and molecular docking on a series of 29 reaction derivatives to predict new active molecule and the less side effects that drug currently exists. This is the structure of the main molecule. The table represents activity and substitute. To do this, we performed a Quasar study on a series of 29 molecules of triazole derivative in order to determine the quantitative relationship between the structure of this molecule and their antifungal activities, in order to identify the structure characteristic responsible for this activity. The rank of activities is between 5 and 0.96 and 7.204. Before building a 3D Quasar, one must go through a very important step called minimization and alignment. The second table gives a statistical value of COMFA and COMSIA. As you see from this table, that's the value of unvalidated correlation coefficient R-square and cross-validated Q-square of COMFA and COMSIA are very high. The table also shows that the value of R-square tests of COMFA and COMSIA are greater than 0.6, which implies that our model has been well validated. Following figure the contour maps of COMFA, steric, and electrostatic. The green contour shows where large groups are favorable, unlike the yellow contour. The blue contour shows the substitution of electrodonor groups, increasing the activity, unlike the red contour. Some explanation for COMSIA contour maps. The following figure summarizes the contour generated by COMFA and COMSIA. So, based on these contour maps, we have proposed new molecules with more important activities than those of existing molecules. The molecular docking result shows that the predicted compound P1 exhibits several and different interactions with the protein compared to compound 12, which is the most active compound of the series. Thus, compound P1 has a high affinity energy value of molecule 12 of molecule 2 are as shown in the following table. In the aim to predict new molecule which importance antifungal activity, the COMFA and COMSIA model have a good statistical results. The results of contour maps are used to determine the region influencing the activity. We have proposed two triazole derivatives with high predicted activities. Perspective, perform calculation with new methods, admit prediction and molecular dynamic and 4D Quasar. Thank you for attention.
Thank you for your speech. Have you got any questions to Barbara? Maybe no questions. Thank you for again. Thanks to all participants, all studies were very successful, and I wish everyone succeeds in their work. First of all, we would like to thank the organizers of the Congress on behalf of myself and to all participants. Hope to see you all in a different Congress. We wish everyone healthy days. Okay? See you later.
Hocam bir kongre için şey alalım. Kitaba fotoğraf alalım.
Olur. Harika. Yes.
Herkes bakabilirse. Kameralarını açarsa.
Open your camera please for photo.
Tamam, yok galiba. 1, 2, 3. Teşekkür ederiz.
Thank you.
Çok sağ olun hocam.
Ben teşekkür ediyorum herkese.
Benim bir sorum olacak. Bu şeyleri, fotoğrafı ve kayıtları alma imkanımız olacak mı yoksa?
Kayıtları paylaşamıyoruz sizinle. Biz etki vermek istediğimizde kimse istemediler. Çünkü kendilerine kaydedilecekti. Fotoğrafı da kongre kitabının içerisine ekleyeceğiz.
Anladım. Sunumu ama veremiyorsunuz öyle mi?
Yok, sunum veremiyoruz ama YouTube kanalımıza ekleriz. Sunumu oradan görebilirsiniz.
Tamam. Tamam. Teşekkürler.
Teşekkür ederiz.
Teşekkürler.
Görüşürüz.
Have a good day.
Tamam.
Okay.
Teşekkür ederim.